Welcome to the meetup. I'll wave. You've never seen you. Yeah, they were looking for you. Cool, let's start. Before we start, we'd like to begin by acknowledging the Yugera people, traditional custodian of the land on which we meet today, and pay our respect to their elder past and present. Extend that respect to Aboriginal and Torres Strait Islander people here today. My name is Clara. I'm one of the engineers. Whatever. I'm tired. I'm one of the organizers of this group, and I'm also a backend engineer at Convert. I'm your host for tonight. Those are the other organizers of the group. You can see them around, so if you have any question, want to say hello, feel free to find us around. I think Alan is not here, but all the others, it's going to be your job to find and spot them. What's going to be tonight, we're going to have Lucy talking through some AWS announcement, and then we have a couple of presentations. This is to keep you on your toes. I swapped the order. So first, we're going to have Denver, Behind the Hype, bringing AWS Agentic Core into everyday business. Then we're going to have pizza and some networking, chatting with your friends, get to know each other. And then after pizza, we're going to have Michael talking about observability in LLMOps. I can't talk at all today, so please do not come and see me later. Before we get right into it, just what else is happening in the community. There's a serverless meetup as well in Brisbane. So if you'd like to go, the next event is on the 4th of November. And the content is Ilya is not here today. So I think he's talking in the Gold Coast meetup. But you can reach him out in LinkedIn if you want. And I think this is all the housekeeping for now. So I'm going to hand you over to Lucy, and I'll see you right after that.
There we go. Okay, cool. So we're going to go through the what's new on AWS since our last meetup, which was on the 16th of September. Let's get started. So since our last meetup, we've had 20 distinct updates. This was all told to me by Gemini. Not going to lie, it was a lot easier to find the details. And over those, out of those distinct updates, there were 50 major, full updates in the month. And 7 of those were related to AI. Tonight we're going to go through 5 of those, just to keep things fresh and easy. And then you can actually hear the more important talks. Cool. So the first one is probably, if you're anyone here who does security, operations, management, of course, Rowan. Anyone else? Cool. Awesome. So this announcement is related to AWS IAM Identity Center. So it now supports customer managed KMS keys for encryption at rest. So the reason why this is important is because previously it would only support AWS encryption, which didn't allow you to use your own keys. You couldn't manage them yourself. For example, if you wanted to have your own lifecycle policies, or you wanted specific keys for specific areas of your infrastructure, you had to use what AWS provided. This allows you, the pros of this release allows you to control the key management more, allows you to give more granular access to who can access those keys, and also gives you more visibility in auditing. So it does allow it integrate into CloudTrail to view who's using those keys and when they are in use. However, there is a bit of a con. So firstly, with any of the CMKs, there will be additional costs because you're requesting for those additional keys. Additionally, is if you're using any of the AWS managed applications with Identity Center, they need to be able to use the CMK as well. If you can't, you have to go back to using the AWS keys. And then the other thing is there is a risk of misconfiguration. So if you ever decide you have someone going rogue and accidentally deleting those CMKs that you have for whatever reason, or they've changed the permissions, there is the risk that you can't use your IAM Identity Center anymore, which is problematic considering that should be the access to everyone for how you access the accounts. Cool. Sweet. The next announcement I have here is Amazon ECS managed instances. So this one is very interesting to me. I manage multiple containerized environments for clients. some of those are EC2 backed, some of them are Fargate backed. For me, it's been a challenge to convince people sometimes why EC2 backed ECS clusters can be a bit of a pain to manage, and it's also just generally annoying to manage. So the AWS ECS managed instances release gives you like that happy medium, as in it allows you to utilize the EC2 backed ECS cluster, but it also means that you don't have to manage it yourself. So AWS will look after the patching, it will look after the cluster management. So one part of, if you've ever used the EC2 backed, you spend quite a lot of time ensuring that every single EC2 instance is properly utilized by the Docker containers, and then you're paying extra costs if it's not. Whereas AWS will manage that for you, so it allows you to save those costs from constantly that overhead of management and reduces your costs and TCO overall. The other thing that's really great is, from an operational side, is it does allow you to use your existing savings plans or reserved instances, which if you have got that cost requirement from your business, and you have explored it, they are great. The compute savings plans are amazing for covering all your compute resources. So I highly recommend having a look into it. Gonna caveat, it's not yet in Sydney, because I got very excited seeing this, because I saw a great use case for a client. Not yet in Sydney, but keep an eye out. Yeah, it just looks like a great service, honestly. If you've ever been in like an operational side of had to manage those clusters, highly recommend.
You ever wanted Fargate but with GPUs? That's your answer.
Yeah. Cool. And it wouldn't be a meetup if we didn't discuss a Gen AI topic. So the first announcement for the Gen AI area is DeepSeek v3.1 model is now available in Bedrock. So it's an advanced open weight model introduced to Amazon Bedrock, fully managed and service offering. So I'm not an AI person, very open about it. For those who are AI people, let me know how it goes. Enjoy your time. Just out there. I'm not an AI engineer, I'm an operations person. Cool. The next one wouldn't be an AWS update if there was not EC2 instant type upgrades. So I'm going to say from an operational lens, it's always important to review your instance types regularly for not just cost, but performance, see what new tech's available, just better off generally. And also if you care about sustainability, meet your sustainability quota. So Amazon has released 2 new instant family upgrades, the first being a general purpose M8 instance, and the second being a compute optimized instance. So yes, these are not yet available in Sydney. I did have a look, but definitely recommend once they come out, play around with them, see if they work with your workloads. It's a potential to both improve your performance and your cost, as well as utilizing newer technology. Cool. And the final upgrade, again, another Gen AI one. Claude Sonnet 4.5 is now available on Amazon Bedrock. Normally we'd have the joke that Claude wrote the what's new page. Unfortunately, that did not happen today. Not today. But like I was, again, not an AI person, but definitely recommend those who are. Please play around with Claude Sonnet. Let me know how it goes. I am actually interested if you can make it better. Like I know Mark has before made the what's new on Claude. So thanks, Claude, for all your hard work. But again, it's been released. And that's it. Thank you. There wasn't many announcements to pick from, so a little Gen AI or operations.
All right, welcome everybody. It's nice to see all of you, some familiar faces, some new faces. And today I'm going to be talking about Beyond the Hype, Amazon Bedrock Agentic Core in business. So most of you guys are on AWS, I'd assume. If you're not, get on there now. You should be there. This is not a paid-for ad. So Agentic Core has just gone full production about 2 days ago. Is anyone running any production workloads at the moment? It's a little bit too early. Yeah. Oh, Mark, of course. Yeah. All right. So I have a genuine appreciation for the tools that have been presented in this, and I'm going to talk about that in a second. So about 2.5 years ago, when we started creating this AI-first company, a lot of the tools we had to build by hand. We were writing code in different languages, trying to find the best embeddings database. We started to use things like OpenSearch and paid a lot of money and realized don't use OpenSearch. And getting to this point where all these tools are being refined so rapidly, being delivered at scale to production, you can use this in enterprise systems so quickly, it's refreshing, and it's also a time that it's really great to be alive. So what I'm going to talk to you about is Agent Core and the Agentic platform. So by the end of, I can walk around, right? Yep. Yeah, okay.
Sounds good.
By the end of this session, I'm hoping that I can communicate in the simplest of terms so all of you understand what Amazon Bedrock Agent Core is. It's actually big, it's huge. It's probably the biggest thing since large language models. And when you start using it, you're going to realize how powerful it is. And I think this room is hasn't succumbed to that fear, uncertainty, and doubt that's out there about AI taking your jobs. Does anyone feel like AI is going to take your jobs? No? Yeah, because I mean, we're all good developers, right? There's things we can do that the AI cannot do. So this is what the Amazon Agent Core platform looks like. So we've got the enhanced with tools and memory, deploy securely at scale, gain operational insights with agentic operations, and that's observability. And right at the bottom, we've got open source tools that we could use like MCP and agent strands. So right now, all of that's just terminology. I'm going to break this down very simply so we're all on the same page and understand how this works. And we're going to do a live demo. We are going to defy the demo gods and do a live demo. And and we'll have some questions. Okay, so what is an agent? In the most simplest terms, an agent is software that can pursue a goal with limited supervision. So let's take an example of, suppose we had someone working with us named Kelly, and we wanted Kelly to do a calendar booking. Very simple, but this kind of thing can be really frustrating because Kelly is going to try and book a meeting with Laxman, but Laxman's calendar might not align with my calendar. There's got to be some back and forth. And it's a simple thing, but someone's got to do it. And right now, there's a few things that needs to happen. You need to be able to talk to Laxman's calendar. You need to be able to talk to my calendar. Kelly needs to send some back and forth emails, arrange all of this, make sure that we could get a meeting. And that's just step one, because once you get a meeting, what platform are we talking in? Because nobody wants to use Microsoft Teams, right? Can we say that, Mark? No? So you got to figure out all these things. and the whole thing is software can pursue a goal with limited supervision. So what if we took a goal like that and we gave it to software and we said, how about you take care of that tedious, mundane, heavy lifting, and we'll go do the high value stuff, like we'll arrive. It's kind of like, if you want to go somewhere and you got a driver, you just get there and you arrive and you do you and you let the driver do the driving. So that's kind of what we want the agent to do. And at its lowest level, this is what the agent's going to do. It's going to pursue a goal. But how does it actually do that? There's 4 basic building blocks. One is it needs to perceive what needs to be done. So let's take the Kelly example again. If Kelly's going to book a meeting, we need to give Kelly some context, some user input. Kelly, I need to book a meeting with Laxman, and I need this meeting to be booked this week. Maybe it's enough context. Kelly can go out and try and figure out what to do. That's the input. Kelly needs to plan that. Next steps, do I go and open up my calendar and send out an invite? Don't know what Laxman's calendar is. Or do I send an email and say, oh, these are my available times? Or do I get some kind of third-party software that requires even more moving parts? Because if I get something like Calendly, maybe Laxman doesn't have Calendly. Maybe he's using Google. So there's all sorts of things, and Kelly needs to plan these steps. After planning these steps, Kelly's going to be able to act on it. So calling tools or APIs, maybe Kelly's not quite doing that, right? But she's going to have to act on it. She's going to have to send that email to Laxman. Are you available this week? Yes, I am. Are you available on Tuesday? No, I'm not. How about Wednesday? There's a few back and forths. So Kelly's going to have to act on that. And then the last part is reflecting, checking that result. So every time there's a back and forth, Kelly needs to figure out, okay, is this the right answer? If it's not, then I'm going to have to go and act again or plan again. So Kelly's going to carry on until the actual task is finished. And now we're going to take that same scenario, and it's a very simple scenario, and we're going to take that into the agent world. So the steps in the agent world are a lot more involved than just sending out that calendar invite. Most of you are developers here, I'd imagine, or some kind of developer. Anyone not a developer? Anyone like a project manager? Oh, I'm sorry to hear that. But you guys understand that doing anything with code, there's a lot of moving parts. There's integrations, there's APIs that someone wrote that just doesn't work the way we like it to. And the moment we look at someone's external system, we probably want to rewrite it because it's written so badly. And we find that there's so many moving parts. Now, if we go back to the agent world and we look at the perceive, plan, act, and reflect, those 4 basic blocks, that can be broken down just a little bit further. The user receives the inputs. That's the context of what the user needs to do. And then process the inputs. Now, processing the inputs in the agent world, we use large language models. Previously, we had machine learning models that we created ourselves, and it only had a limited set of data. But now these large language models kind of help us out like really quickly with these kind of things. So we'd use a large language model as an example to process that input to figure out what to do. And then we can use tools to gather information and actions. The tools that we could use would be, let me get access to Luxman's calendar. That's an example of a tool. And then we want to execute those tools and receive results. Now that I've got access, I want to be able to get all the information from Luxman's calendar, figure out when it's available. And we all know that there's security and all sorts of other things that need to be taken into consideration. There's the continue of reasoning, so the back and forth that we spoke about, and we need to get the final result that's produced. Now, this topic, I'm just touching the tip of the iceberg. It's a huge topic. In fact, this is like at the top of the pyramid. Everything else that we know still exists. It's still there. There's still hardware. There's still networking. There's still memory. There's all sorts of things that we're familiar with, and it still exists, and it still needs to make everything work. So with the agent building blocks, if we had to take that and translate that into how do we create a single agent? How do we create agents talking to each other? How do we get actual actions done? So a calendar booking is a very simple thing. Does anyone have any other wishes, like your agent being able to book your flights and get your ticket delivered to you and get the guy arriving at your door fetching you? Sounds like you could get kidnapped, but yeah. See, these are kind of things that are possible today. And whatever you dream of, whatever you think about in the real world, this is where there's a little bit of a bridging of the gap. You don't have to live in the bits and bytes. You can have a human in the loop, but then there's also the opportunity to execute things that humans used to do, the tedious and mundane tasks. Like booking the ticket, that can happen without the human, and this is where agents come into play. And I'm going to go very quickly and explain just the high-level concepts. So when we look at models, this is the reasoning engine that plans and writes. These models that we're all familiar with are large language models. Anyone not familiar with large language models? It's okay if you're a project manager, though. So we're all familiar with this. We started using ChatGPT, we were wowed, and then we were like not so wowed, and then we saw the next thing, we were wowed again. And these large language models it's a mammoth, gigantic thing by itself, but now it's become a piece of the puzzle, just a little piece on the puzzle. So models are going to help us with reasoning. It's going to be our reasoning engine. Some examples are Claude, GPT-5, Grok, etc. There's a lot. There's so many that we probably will never use. Tools are actions that agents can take. Example, browser use. You might have seen the browser use by Anthropic when it first came out, and it was like, wow, and then just like everything else, not so wow. And most of you would have said, oh, this is probably just what we could do with Selenium or some other way. You know, we kind of understand how to do that. But you'll see there's a pattern emerging here. There's all these tools that are coming together. Then there's APIs and lambdas. So my friend over here just told me he doesn't like lambdas, right? No?
No, I don't.
You better start liking them again because they're making a comeback. So lambdas are the smallest unit of compute that we know of in AWS. And lambdas used to exist on their own, and then eventually they started to get some kind of API into it. Previously, we had plummeted some API gateway. Now there's another layer, and that's the agent core gateway that allows us to interface into Lambdas, interface into APIs, into other systems, making things a lot more open and a lot more connected. And then there's prompts. Now these are instructions and contexts. It's almost like when your project manager comes to you and says, "How you doing, buddy? How's that project going? Are you going to be ready on time?" So that's like, kind of like a prompt. You want to give context and you want to give instructions. And this is something we've learned very quickly as well, because we understand how to prompt large language models. Now, keep these three things in mind. There's three more I want to talk about. This is knowledge. Now, knowledge bases, we would have seen lots of systems now that you can interact with, and you have knowledge bases that you could talk to. If you're working with AWS for a long time, you might have used Comprehend or some other platform or service like that. But now we've got knowledge bases that we can create, and a lot of this is driven by RAG, and that's retrieval augmented generation. And with RAG, there's various vendors that provide that. So one of the vendors is Bedrock knowledge base for RAG, and this is fairly new. It kind of brings all those embeddings together, and just like all of these things, they can go into much larger topics. So I'm going to keep it very high level. What this means is if you've got company information, you can take all your company information and you could read it out to Kelly, and Kelly's the new employee and she understands it. Or you could point your agents to all your company information and start speaking to your agent and let your agent make decisions based on that knowledge, and also understand and retrieve that knowledge very quickly. If you've used ScarePoint a long time ago, you know you put things in a black hole, it doesn't come back out. But now it's changed. Every little bit of information that we have, including metadata, can be easily accessed in a matter of milliseconds. And that's the knowledge base. The next is memory. With the large language models, again, we are familiar with the small context windows that we were first exposed to. And then those context windows started to get bigger. But that memory is very limited. So there's short-term memory where we're having a conversation right now, but that conversation can continue. So if I started speaking 10 minutes ago, and what I said sentence 1 or sentence 2 might not be relevant right now. So that kind of gets summarized and put back into long-term memory, but still available. So you can conceptualize it like that with short-term and long-term memory in that particular conversation or the task that you're doing. Then there's orchestration. The agentic loop that we spoke about earlier, those 4 steps, this is where you'd want to go and perceive the information, act on it, and go through that entire loop as many times as necessary to get the final answer. And this is where AWS Strands comes in. So I've given examples of all the technologies that fits these pieces that we would have had to once upon a time build. And the last 3, the bottom, or identity and access, which is security, is probably the first thing you should think about. We still need to be able to make sure that these agents can securely access systems. Now that they have more access than they had previously, we want to make sure that they have the right access. Cognito is one example that you could use. You could use Okta. So all of these existing systems that we have allow us to connect securely to other systems. Then there's the policies and safety. And this is your guardrails, where we govern the outputs and we govern what tools can be used. So one example might be access Laxman's calendar, and another action might be delete Laxman's calendar. We probably don't want to do that, so we would govern that with guardrails. And then there might be private information that's confidential, like HR information, that you don't want people to get access to, so you want to be able to put guardrails on that. And that's where it helps with hallucinations as well. If we know what the hallucinations are, and if we're keeping our topics narrow, in business, we can actually say, okay, don't answer any of these things that might give an opinion on how someone could take care of their mental health, as an example. All of that brought together is the agentic core runtime. This is where it all runs at scale. So all of these things are brought together. They're all little building blocks that speak to each other. And the agent core runtime is how all of this actually runs. Now, coming back to the development, any development we do, there's CI/CD pipelines, there's CDK, Terraforms, etc. And we got to bring these things together in one way or the other. And when we do bring them together, they don't always fit. And what we've got here with the agentic core runtime, this is the beauty of it. It brings everything that I spoke about together, making it easy to manage, easy to deploy, easy to run in production. And with the Amazon Bedrock Agent Core, it's a platform that you can deploy and operate agents on any framework or model securely at scale. It's serverless execution. It can host things like MCP servers and agents. And most importantly, it is enterprise grade, and it is ready for use right now. So this is a very high level, and as you see, the time that it's taken me to explain just some of these concepts, it's a huge topic. So what I'd like to do is show you a little demo of this in production, how this works, how all of this is brought together, and how we actually use Amazon Bedrock Agent Core to perform a lot of these tasks. So here's what I'm going to do. Do I have 5 more minutes?
Yeah, keep going.
All right. Yeah, good crowd. Yeah, fantastic. Let's turn off the lights and turn off the music. All right, so can I get some random volunteers that I chose earlier? So Laxman. So Laxman, Pratesh, and Funny. That's Funny. That's really his name. I kid you not. I've looked it up. His name is Funny. Am I the only one who finds that funny? Maybe. Okay. So here's what I'm going to do. I'm going to take a typical scenario that we're all familiar with. We have video conferences. We use different tools, and this happens on a daily basis. It's one of those things that actually enables us to work remotely and work efficiently when we're working remotely. But has anyone ever been to any of these meetings and you get there and it's like, oh, can you hear me? Sorry, I can't hear you. Oh, we're waiting for Tom. Is Tom here? Yeah, we've seen that. We have that every day. So what we decided is we use Agent Core to solve that problem. And I shall share my screen. And like I said earlier, we are going to defy the demo gods. So I'm going to go into a meeting that I set up earlier. This meeting was meant to start at 6. So for demonstration purposes, you can take your phones off silent, and you can turn off the volume on your machine. So I'm about to start my meeting, which is the live video meeting, which is the Amazon Bedrock Agent Core live demo. And because we're running late, people are probably waiting. Some people have left. Let's see what happens when we get into this meeting. OK, it's just me. I'm going to choose my camera and use my good side. Don't have one. All right, so I'm in the meeting, and I'm alone. We need more people. So what I'm going to do is have a look and see who else was meant to be on this meeting, because I've set up this meeting. It's in my calendar. And let's go ahead and grab Zeli, which is our agent that's going to help us. All right, are we live? Are we good to go? Seems like we are. All right, this is Zeli, my trusty assistant, previously known as Kelly, but I'm just going to ask Zeli, who else is in this meeting? And everything I've showed you earlier, this is now running on Agent Core. It's going through all of those processes. It's saying, let me check. It's going in, it's having a look, and it's looking at my calendar. It's looking up people's information, and it says, OK, we've got Laxman that's on the meeting, Funny and Pratesh, and Zeli's giving me some suggestions on what I can do next. But because I'm sitting in here by myself, I would like to get someone else on the meeting. So let's go with Pratesh. I'm going to say, call Pratesh on his mobile and join him in. So usually someone that needs to be on the meeting is driving because they didn't get the invite or something. We all know they got the invite, they just didn't take the meeting seriously. So Pratesh is on his mobile. Chances are it's like, oh, sorry, I didn't realize this meeting was now. I'll get to my desk in 5 minutes. And we're going to be like, no, buddy, you're going to stay on the call, and we're going to continue having this meeting. So here's Zeli going, finding Pratesh's phone number, looking it up in the address book. Hello? Hey, Pratesh, you were meant to be on this meeting. Where are you?
Oh, sorry about that. I actually just ran into some traffic, but I'm fine.
Why do I feel like I've heard this one before? Okay, anyway, you stay on the call, because I've got one person on. There's other people that's missing from this meeting. So let's take it to the next level. So what I'm going to do now is, we know that Funny and Laxman was meant to be here. We've sent Pritesh an SMS. He's got the SMS and his phone rang. But Funny, do you have your phone on? Yeah, maybe take it off silent so we could hear your phone ring, and we'll join you in as well. Actually, let's do this, right? Send an SMS with the meeting link to Funny. And yeah, I'm gonna do my bad spelling, because that's what large language models are meant for, to be just really expensive autocorrect. So Funny's gonna receive an SMS, and he's gonna get the meeting link. And when he gets the meeting link, he's gonna be able to click the link, join directly from his mobile, and get into the actual meeting. So I'm not gonna call Funny, we'll just keep him on the meeting. And actually, I lost track. What was I doing? What was the purpose of this meeting? So this is the long-term and short-term memory that I spoke about. Zelly's remembering everything from this conversation, but using tools to go out, get information, act on that, make phone calls, send SMSs, and do anything else that we require, just like we'd have an assistant on the team. So in this case, we see that we've got, oh, Funny, is that you on your mobile? Funny, you're late. Why are you late?
Bad internet.
Bad internet. Okay, I've not heard that one before, but thanks for joining the meeting. Stay on the meeting, and I think we have one more laggard. There's one more person that's missing. So, oh, finally, you arrived. Thank you. So we've got Laxman on the meeting. And now what we've done is we've used the entire Agentic core platform to go out, do things, but we don't have to stop there, because now we've had this meeting. There's got to be some outcome from this meeting. And let's send an email. So I'll instantly receive an email about highlights, but there's a little bit of a cheat code in here. As meetings go on and they go on longer, and this has happened to me many times, I'm sure it hasn't happened to you, when someone says, "What do you think, Denver?" And then you kind of like, oh, yeah, I think that's a good idea, we should go for it. And now we get to ask Zelly, what should I say next? And having context, Zelly understands what question you've been asked, what you should say, and we have suggestions as we go along. And this allows us to maybe reference our own information that we had, reference our documents, reference architectures, draw diagrams, etc. And yeah, based on the meeting context, you've successfully demonstrated Zelly's coordination capabilities. I don't know, did we successfully do it? Yeah? No? All right. Okay, so I'll stop there. And as you can see, there's just a whole lot more things that we can do, and I want to be respectful of our next speaker's time as well. So this is Agentic Core. This is just one example of what you could do. And I really wanted to show that we don't have to stay in the world of bits and bytes, because we can actually make that phone call, get Zelly to call someone, speak to them on the phone, and actually tell them, look, these are the things you need to do. Come and fetch me, or go ahead and create this piece of work that we need. And if we do this and orchestrate this in a way that's efficient and gets the outcome that we want for the jobs that we're doing, I think that the sky's the limit. And with that said, I shall stop right there. Thank you. Back to color. There's always
pauses wherever you're going. What do I say next?
There's a lot to read, like you need to learn fast reading. Like, what do you think about that? Like,
So look, it's cool to see a Agent Core example in the wild already. I mean, obviously it's been around for a little bit, but what made you jump on it so quickly? Like, I've had to play with it, I've looked at it. I mean, yeah, I'm more of a security guy, so it's not my forte, but it's a hot topic, you know. So what was the thing about Agent Core specifically that made you go, this is how we're going to run it?
okay.
This is what we're going to use?
Yeah, sure. So I'll give you the short answer. 2.5 years ago, when we tried to plumb everything together, one of the things we needed to do was solve the problem of hiring. And that required a lot of phone calls to candidates and having those communications. We built that with AWS Connect, if you guys remember that. So we plumbed everything together ourselves, and we had to do the entire array of things, and it was hard. And then we started to get access or previews to some of these technologies, and we started to work with it. So we've had the concept running in production, but now that the tools are available, like the agent, Bedrock, Agentic Core, these names are long, we decided to try it out in preview mode. It worked really well, and now that it's ready for production, we decided to just go for it. We put it out in production like 2 days ago. And the security is still using Cognito. It's using all our existing technologies, just a little bit of plumbing to bring it together. And we realized things that took us weeks and months to do, we can now do in days. Cool.
Yes. How effective are the guardrails you have in place? I know it's a subjective question. What's the error rate, or how do you define that?
Yeah, so the guardrails work pretty well. So I'll go back 2 years ago, it was really bad. It started to improve a lot, and with it being native to Bedrock now, you have a lot of flexibility on the guardrails. So it depends on what your use case is. One use case that we do use is hiring, and the context stays on hiring. We've tried to break it. Pritesh tried to ask it where he could buy weed from. In the early days, it told him that. Now Pritesh doesn't have a weed guy. So we try to break it all the time, and it's gotten much better. So we've even seen candidates try to break it, and I think it's pretty good now. We haven't seen anyone go off the rails. Yeah. Hi.
How would you describe the cost in terms of, just every services associated? What are the most probably cost-consuming services out of the agentic core?
So being fairly new, the only cost indication I have is what I see on the AWS website, because we weren't being charged. Pritesh, we weren't being charged for it all as well? No, we haven't. So, but I've had a look at it. And so the theory that I've seen is if you make, I think it's 50 million calls, then it's going to cost you about $7,000.
If I may, they actually release the pricing so you can find it on the website.
Or we could get the bill, yeah. Yeah, but also just to add to that, I have been pleasantly surprised with the pricing, because early days we ran EC2s that ran into thousands of dollars overnight because someone forgot to turn it off. And now that a lot of this is serverless, it's just fine, it works well. Hi.
I have a question, because right now I understand there are very similar products on the market already, but some business, they have very strict restriction to use this type of software. How do you plan to meet the compliance request?
Okay, so I'm going to give you a little bit of my opinion. I've been doing this for maybe 25 years now and working with enterprises. Enterprises have a lot of red tape for the sake of red tape. And sometimes you need it, but things take a long time. And my opinion again, so please quote me on this. There's people that's been in the organization for a long time that don't fully understand things and they don't move quickly. So they keep those guardrails on there and they don't allow you to bring this in. When the cloud started to take off, people said, this is so, it's not secure, etc. But all you needed to do was make sure your compliance is, you're following the compliance rules, you're making sure your security is taken care of. Because this is just another piece of software. I mean, I don't want to dumb it down like that, but it's just more software. And you use the same kind of guardrails. There's been a new ISO standard that's come out for AI in the past 12 months. So a lot of people are kind of gravitating towards that, but it's still not a hard requirement. So these are things that you can do, but it doesn't change anything else we've been doing, SOC 2, ISO compliance. We still do those things. We still use things like Cognito and Okta, OAuth. All of these things still exist. So it's more a mind shift change. That's my opinion. Hi.
You frequently use when you said Cognito. So when you say you're using Cognito for the purpose of authentication, I assume, you mean against the agent itself, not just when I played with Agent Core, the limitation that I found was I could use Cognito to authenticate against my agent that I built, but then my agent reached out to other data sources, and I couldn't find a way to pass through like that user's context to the other data sources that it was going through to. So So when you're saying cognito, you're saying like against the agent, and then how have you solved that problem of making sure that users using your agent implicitly get access to other data, like other data that they wouldn't normally have authorization?
I see where you're coming from. Yeah, absolutely. So the first part of it, cognito handles, where the agent is authenticated, but then the agent needs to be authenticated against any other third-party system. So you'd still use OAuth, you'd still need those tokens to be able to connect to the other system. So you do need another level to be able to interact.
Through agent call, were you able to get that to work through agent call?
So one of the things we've done here is we've got cognito that's integrated with Google, so Google OAuth. So because they're already playing together, they can work, but there's a problem if we haven't authenticated with another system. So you're going to have to use another form of authentication. One of the things is with ATSs, we'd get the key and then we'd securely store the key, and I think the price changed or something today, and we'd still get the agent to take on that identity and speak to other systems. Coming back to you earlier, one of the risks is because the agents can do so much more, they can actually do so much more damage. So if this kind of security is not in place or someone doesn't understand it, then you could actually get into payroll and change people's payroll and things like that. And all of this is quite easily done if you have the key.
So I think part of the answer, this is on my partial understanding, agent core identity to solve the problem you have described about how do you identify the agent itself. But I don't think they've released all the features.
No, for me, when I played with it, it's kind of like you create a service account to access all the knowledge bases, and so the service account has all the permissions.
Yeah, so that's meant to change at some stage because obviously that's not going to work at scale.
Yeah,
So
that's what I do.
This agent has this context and can see these things, but can't change payroll. You know, it can read payroll. But it's
yeah, we have something called sub agents, like co-agents. So each agents have its own limitations, certain kind of things. So one agent can talk to another agent. So that's called agent to agent. So there is protocol called A2A, just like MCP. So MCP is like connecting different kinds of APIs, but A2A is agent to agent. So certain agents can have limited knowledge. That way they knows what to do. So that way you can control. And other thing is like you can use API key, like third parties. You can use API key, you can store API key in secret manager or something based on the user. So that way you can control those.
Hi.
How do you handle cost and then I guess like the on cost to your customers when you're working in such a dynamic, or someone shoves in a document that's got a context window of like 4 million?
Yeah.
And handle that, like, you know, we see a lot of like, you know, the I guess browsing stuff where it's like, hey, you get tokens and all that kind of thing, but I guess maybe in an enterprise space that's a bit of a harder sell.
Yeah, I think with AI, a lot of people were trying to figure out the cost model. And we also have the same problem. We introduced the concept of credits because we thought everybody understands it, and not everybody understands it. And what we found is not everyone consumes the same amounts of resources. So you get people kind of offsetting it. At enterprises, you kind of give them the higher price, and you kind of just hope for now that they don't exceed it. But we did have a situation, we do have guardrails on. So what we do is we block it when there's too much, or like maybe 10 times the use that we expected. And we've had people do that. We have someone just like feed it like every piece of document that they had, and within minutes it just kind of stopped. It's like, well, you've reached your limit. Yep. Yeah, and we've also had another situation where we were testing. We've run about, 25 million Lambda calls, something to that effect. And it got very expensive in a matter of minutes. So we made sure that there's guardrails around all of those things to actually stop them. All right, so thank you. Thanks, everyone. Good.
Good evening, everyone. My name is Michael. Thank you for having me here. I was nervous when I heard that Denver was presenting before me because we're both talking about Agent Core. I thought, gee, I wonder how much overlap we're going to have. Thankfully, I think that's a nice synergy because you've covered the product more generally, and I want to drill in specifically on observability. So the genesis of this idea, I guess, came in June or July. I think we had Mike Chambers here, and it was just after the New York Summit when they'd released Agent Core and Strands in preview mode. And he touched really briefly on observability. I hit him up and I said, hey, Mike, can you talk a little bit more about observability? I think it's kind of important. He said, you're right, it is important. Maybe it's a good presentation topic. So that's why we're here. LLMOps. Obviously, Clara stumbling over the acronym, yet another ops acronym, is an indication that we have too many ops, which is unfortunate, but kind of unavoidable, because each one of these different types of ops, whether it be DevOps, MLOps, LLMOps, or I hear there's even now agent ops, much to my horror. I guess the reason we need all these ops terms, you lost me? It'll come back, I hope.
Cool.
Awesome. I'm going to go full screen. There we go. They're all a little different. And while they have some common foundations, I think all of the principles of DevOps are common to all of them. There are sufficient differences that they probably kind of deserve their own name. So in order to try and illustrate why I think LLOps matters and why observability should be part of the conversation in the development cycle, we're going to start with a couple of failures. So let's imagine that you're a social media company. Let's say it's called X. And X has got a really famous model called Grok, which has been shooting the lights out on all the leaderboards. People say, hey, Grok is the latest and greatest thing. You go to sleep on Friday night thinking, hey, everything's awesome. We have the best performing LLM in the world. You wake up on Monday and the heads are, Grok goes off the reservation and starts spouting praise for Hitler and other right-wing craziness. Now, what exactly went wrong there? And clearly we didn't have a bunch of failures. The thing continued to work. It was continuing to deliver output. But the output was no longer aligned with what the developers, or more importantly, the consumers, were looking for. So how do we capture that? How do we measure it? And how do we try to keep it on the rails before something catastrophic happens? When I say catastrophic, it might seem like an overstatement, but I think in all cases, reputation is one of those things that's very hard to earn and very easy to lose. And nowhere is this more true than in LLM-powered applications. It doesn't take a whole lot of failures for people to suddenly become very cautious and very untrusting of your product. So being able to consistently deliver a product that's not only accurate, free of hallucinations, biases, but also that's delivering the message in the right tone consistently is really important to keeping that trust amongst your consumers and keeping your product valuable. I mean, I don't know if anyone else feels the same way, but Grok is kind of well and truly out of the limelight. It doesn't get a mention most of the time now. And I suspect a lot of that has to do with the amount of public trust that was lost in the course of these repeated problems that they've had. I'll give you one that's more of a hypothetical, but perhaps more relevant to the people in this room, because let's face it, we're not all Elon Musk. Hypothetically, we develop an agentic system. It's a customer service bot for a medical practice. And we've worked really hard to get the tone of the bot to be appropriate for that context, where someone who's sick is calling up and they're expecting a particular kind of attitude or feel or vibe from the person on the other end of the line. It starts off great, but come Monday, suddenly it's got really bogan, like someone from one of the poorer parts of Brisbane says, hey, g'day, mate. Yeah, you want an appointment? Yeah, no worries. I've got an opening on Tuesday at 3 o'clock. Will that be all right? Yeah, mate, no worries. She's booked in. Now, I'm willing to bet that pretty much everyone who calls a doctor's practice and is looking for an appointment would consider that to be an inappropriate kind of tone. So hopefully those two things illustrate the point. Observability always gets a mention, but we very rarely dig into it and talk about, well, what do we really mean? And I'm going to go a step further and say that I don't think it's something that we should just think about when it comes to production. It's something that we need to consider from the get-go. And we need to be measuring a lot of these LLM-specific metrics from the beginning. Thanks again to Denver. So I did a really simple and kind of crappy diagram here of all the elements that go into Agent Core, whether it be models, serving models, versioning models, the deployment and development models on one hand, storage, whether that's long or short-term memory, data management and data versioning, prompts and prompt versioning. These are all important. Gateway tools, MCP services, of course, security, identity, access controls, all really important stuff, but thankfully they're covered. We're not going to talk about that. Each of them probably deserves their own presentation. What I really want to talk about is the monitoring and observability and the evaluation parts. Now, I've got to apologize for the use of the word vibe. Everything's right now seems to be having vibe as some kind of preposition. You tack it onto the beginning and all of a sudden it's cool. Vibe coding, the term drives me crazy. So adding vibe here is not my choice. It is actually a term. So there's a research group out of UC Berkeley who published a number of papers on this, and they even have a product now called Vibe Checker, which will help you to make sure that the vibe of your LLM stays consistent. The paper is in the references. Please have a read. It's highly entertaining. Actually, it makes a lot of sense, though. So when I'm talking about what we should be looking at, there's kind of a hierarchy. The most important foundational stuff, of course, is our normal metrics. Is our system reliable? Is it up? Is it fast? Is it connected? Are we getting errors? Everyone's familiar with this, whether or not you work with LLMs. Excuse me. Evals are pretty well known to everyone, I think. We generally want it to behave reliably. We want to avoid hallucinations. We want to avoid things like toxic language. We want accurate answers. And we want it to be doing it consistently as the developers intended. So the vibe stuff is really much more about the experience that the consumer has when they're using our product and making sure that we're consistently and reliably delivering that experience. Interestingly enough, it looks like, based on the research, most consumers, particularly in a business type of context where a lot of these new agentic apps are being deployed, they generally like a short and concise, to the point answer. They don't like GPT-style long, verbose, waffling answers. Let's get to the point. Tell me the truth. Let's get it done. Let's move forward. And they also want it to fail cleanly. No one wants LLM hallucinations. No one wants it to be making up stuff. If the model doesn't know the answer, please say you don't know the answer. That's what I think most consumers would expect. There are exceptions to this. We mentioned medical before. I'm sure there's a ton of other examples that are skipping my mind where people would prefer a different tone, a longer response. There may even be cases where hallucinations are good. I can't think of one, but I'm sure there is one. So how is it different from all the other ops that we touched on briefly? So system health and infrastructure in general, I think we've covered that. ML observability, I'm hoping that everyone's reasonably familiar with this. Most of the time in ML, we're working with predictive models. Let's say hypothetically we were talking about a time series model. We want it to give us the best and most accurate forecast for the commodity in question in the time frame given. Over time, that may drift. We want to keep an eye on it so that it's consistently predicting the right thing. It's giving us the result that we want. LLM's a little bit different. Drift is kind of expected. So we measure drift in a slightly different way. Most answers don't have one canonical truth that you can say, yes, this is the North Star. Any answer different from this is less good. There are often, in most cases, dozens of potential answers that are factually correct and phrased in such a way that they are good. So how do we deal with this? That covers the accuracy. The consistency, I think I've done enough. And tone of behavior is, I'm going to harp on and on and on about this. We hardly ever talk about this, but I think it's probably the biggest differentiator. If you are building a language-powered app, this is the thing that will differentiate you. If you're able to deliver the right information, the right answer, and the right action in the form that the consumer wants on a consistent basis, that will differentiate you from everyone else who's following a cookie-cutter approach. Okay, we covered the non-deterministic thing. So one interesting thing about these kinds of applications is they tend not to fail loudly. You're unlikely to get a customer calling you up at 2 a.m. and saying, hey, my product is giving me a 404 error or whatever, a 500 error, whatever the case may be. Those things happen, of course, but as long as you have your basic infrastructure monitoring and working, it shouldn't be a major issue. Where they fail often is this progressive degradation in the quality of answers or the tone of answers. And we talked about the X thing, but Anthropic recently had a very similar problem with Claude, where for a period of about 4 weeks, there was tons of people who are complaining bitterly about the fact that Claude 4 had degenerated significantly in the quality of its answers that it was giving and the quality of its performance in its agentic coding tools. Claude is still dealing with the PR fallout from that. We talked about not being able to rely on a single correct answer, and we need ranges of acceptable answers. And we also need to establish patterns of behavior that feel right in our context. Unlike arbitrary measures like the number of tokens we use, which is important, things like these patterns of behavior and these kinds of acceptable answers do not have a one-size-fits-all thing, a one-size-fits-all solution. We need to come up with the solutions that suit our clients. I think most of this is kind of known to people, but I'm going to cover it anyway. Hallucinations, everyone knows what hallucinations are. I'm going to suggest that it's not a great term, and I know that that's useless because it's so deeply embedded that I'm never going to change anyone, but I think that confabulation is actually a better word for it. Essentially, I think the LLM is trying to come up with what it thinks we want to hear, whether or not that is true. Some of it bears a semblance of truth, and some of it is outright fiction. To bundle them all under the same word kind of seems a little bit wrong to me. But anyway, it is what it is. Another thing that doesn't seem to get talked about very often is the importance of order. The sequence in which we enter our prompt or our question has a massive impact on how well the LLM responds to the question, the quality of the answer. Newer models are getting better at this, but it's still an issue. Verbosity. I can't think of too many models that keep their answers short and tight. I think GPT is the worst. It really struggles with written diarrhea. It's just not so fun. So coming up with a way, well, first of all, finding the right model that's not going to give you verbose answers out of the box, and then constraining it so that it gives you concise, to the point, tight answers. That's a major challenge and one that we all need to overcome. And tone inconsistency is also a really funny one. Has anyone come across a website called Chatbot Arena? No? Check it out, yeah? Have you used it? What do you think?
On Hugging Face, is it?
Yeah, they have a link to Hugging Face.
Yeah.
Do you like it?
Yeah, sort of interesting.
Yeah, so it came out as a side project out of a little research group at UC Berkeley who were interested in this very topic, and they thought, well, how on earth are we going to gather data on the tone of one model versus another? So they set up this Chatbot Arena thing, and they would serve models, and you would get to try 2 models side by side with exactly the same prompt, compare the answer, and then vote on a particular metric. We'll get more into the metrics later on. It was amazing how much data they got. I think they got something like 5 billion data points over a couple of years, like 18 months maybe. So it was incredibly successful. And they used that data to develop this vibe checker thing that I was talking about earlier, which is really interesting. I have to try the thing out. I've read the paper, but I've yet to try the product. It looks really cool. I think the important thing to note about all of these things is that these aren't bugs. They're behaviors that are inherent in this kind of model. And we don't want to get rid of them. We want to manage them. And ideally, we want to manage them in such a way as they make our product better, not worse. Feel free to cut in any time and ask questions if you want. Otherwise, I tend to just talk. So what do we talk about in terms of the principles of observability? Traditional observability is all about quantifiable metrics, logs, traces, and data that we can go back and look for trends over time, and make sure that we can take preemptive action to ensure that our infrastructure doesn't fall over, our app stays in production, and everything works fine from the customer's point of view. LLM observability uses all of that. It needs all of that. It's absolutely essential, but we need this quality, consistency, and explainability, I guess, as well. A lot of these things, some of these things we've talked about. These are the obvious and easier to measure things, and I thought I'd put them up before I put some of the more kooky stuff up. So hallucinations, again, is really well known. Is the model making things up? Is the app returning answers that are factually accurate? Is it returning answers that are consistent with, say, the ground truth data that we've got in our RAG knowledge base? That's pretty well established. Agent Core already comes with tools for this. RAG performance is a really interesting one. Retrieval augmented generation, if you don't already know, we put in a whole lot of ground truth data into a knowledge base. The LLM can access that, and it has this ground truth that improves the consistency and quality of its returns. There's a bunch of potential bugs in RAG, and you need to keep an eye on how its performance holds over time. A couple of failure mechanisms commonly appear. Chunking strategy can be one of them. Your retriever can be one of them. But the single most common one is your re-ranker. So when your retrieval model pulls data from your knowledge base, it's not in any particular order. It's just the order it came out in. In order for you to pick the best response, the one that's going to answer the question the user asked, you need an effective re-ranker that's going to return the answer most likely. This is the most common vector for failure in RAG. Span traces seems kind of obvious, but as we move from LLM-based workflows into more agentic workflows, which are by their nature far more complicated, we need to have a really clear idea of how our traffic is moving from one component in the system to the next. For example, how do I know if my agent is calling the correct tool? How do I know that it's only calling that tool once and getting the response it needs? How do I know that it's looking up an MCP server at the time it should? These are all the things that we can see from the traces. And if you've never looked at it before, you will be horrified. You will be horrified, which is why you should look at it. Token usage, I think, is something that everyone's well aware of. It's baked into Agent Core. All of these things are baked into Agent Core. It's really easy to keep an eye on exactly how many tokens you're using per model and what that means in terms of cost. User feedback is not something that we talk about too much, but I think everyone's actually familiar with. We talked a second ago about Chatbot Arena, and that's a great open source way of getting user feedback. But everyone should have a mechanism that they've designed into their application that collects user feedback as part of the process. If you use GPT, very often it'll ask you to give a thumbs up or a thumbs down, or it'll give you two different option answers, and you'll pick one or the other. Can anyone guess what the common theme of those examples is? It's a trick question. Well, it's not really. They're binary. So one of the experiments, one of the bits of research that's come out is it's a very bad idea to use things like Likert scales and other soft measures for things that seem qualitative. As an example, if I have a scale from 1 to 5 for how friendly this model is, how meaningful is it when I give it a 4? My 4 might be Rowan's 3. So that's kind of useless. What's the point? Best practice is to reduce it to a binary and say, it's good, it's not good. Yep. And by doing that, over many, many, many different parameters, we kind of set ourselves up for almost like a logistic regression problem, where we can go through and calculate out, okay, from all the parameters I've got, if I'm looking for this, what's the best path to achieve that? So avoid Likert, stick with binary evals, and make sure you build in a user feedback mechanism. Okay, players. Now, obviously, we're here to talk mainly about AWS, Strands, Agent Core. That's probably my first port of call these days. I'm still fairly new to it because it is fairly new. But it's kind of batteries included. So observability is a first-class citizen in both of these product offerings, which is not true for most of the others. Prior to discovering these two, my preferred agentic framework was LangGraph. I really like LangGraph, but it doesn't have observability. If I want observability, I need to import LangFuse. And similarly, if I was to choose Crew AI and I want observability, maybe I want to import weights and biases because it doesn't give me observability out of the box. That'll work, but the more third-party dependencies, the more complexity I bring into my system, the more my life gets difficult. And life is hard enough already. Let's make life easy. So for me, I would advocate for AWS and the Strands solution. Far from the only solution. This is an incredibly competitive marketplace these days. Every time I turn around, there's another startup offering another tool with some new whiz-bang approach to how you should monitor your LLM-powered application. Ultimately, it comes down to what works best for you. So my own thoughts on it, try everything, figure out what you like, use that. Yeah, next one. So I think the Strands and Agent Core together are a really nice match. Denver talked a ton about Agent Core, and it covers most of what we need, but he didn't dive much into Strands, and unfortunately, I'm not going to have time to either. Strands is quite different, I think, from a lot of the agentic frameworks. Most of the observability things, tools that you will need are already baked in. It's just a matter of setting up the decorator. Add the decorator to the functions that you want to monitor. I really like it. It's simple, it's elegant. It's a lot easier than the LangFuse way. Collecting all of this data helps us to start analyzing it and move towards improving that user experience, which ultimately is the only thing that's going to keep your consumers with you, using your product and paying your fees. Yes, sir.
So all of this is built in, but where does it end up? CloudWatch?
CloudWatch.
X-Ray?
CloudWatch, yep.
Do you have to use X-Ray at all?
No.
Okay.
Oddly enough, no. It looks a ton like X-Ray to me.
You said spans and stuff like that.
It sounds exactly like X-Ray, right? Yeah, so I think they've drawn a ton of inspiration from the way X-Ray does things, because all of the same terminology applies. If you go to CloudWatch, I'll make a mess of the display, but if you go to CloudWatch, look at the left-hand menu, down in the bottom left-hand corner, there's one called Gen AI Insights, with the little new label. You have a look at that. Best populated with data first. Otherwise, there's nothing to look at. But as we talked about, and this is where we get into the weeds a little bit perhaps, latency, hallucinations, number of tokens we use, and all the things we've been talking about so far, they're important, but they're not what's going to set you apart. As we said, correctness is only part of the story. It's the way that the product delivers the response that really separates a great product from a not so great product, if every other technical thing remains equal. So I'm going to adopt this vibe term as much as it bugs me. I can't think of a better one. I've been trying. So we need to be monitoring and measuring and optimizing for vibe. And that is really an operational concern more than anything else. So it's the job of developers and engineers to make sure we establish this and that we monitor this thing on an ongoing basis so that our customers feel that rapport with our agent that you yourself will have experienced at some point in time when you've been using a tool and you're like, hey, this thing really gets me. It really understands what I'm asking for. I'm getting the results that I want. It's explaining it to me in terms that I understand. That kind of rapport is what really matters just as much as accuracy. Unfortunately, measuring this stuff, and we talked about having binary metrics and treating it like a logistic regression problem, this one doesn't come with any of them as far as I can tell, except for maybe a vibe check, yet to be confirmed. So in most cases, you're going to need to build that yourself. Fortunately, it's not particularly hard. If you look at some of the resources that I've included in the presentation, it'll lead you to not only the papers, but also all the GitHub repos that show how other people have done this. While it is relatively recent, I think the most recent paper I put there was released last week. It is all pretty new sort of stuff. Everyone is being very open about their research, which is somewhat surprising, and publishing most of their code. So no one need reinvent the wheel. all we need to do is stand on the shoulders of the giants who've already set this path for us and take inspiration from what they've done and ask ourselves, more importantly, I think it's right that there's not a one-size-fits-all thing, because our customer bases are all different, right? Every product that we build has its own unique customer base, which needs its own set of facts, its own feel, its own vibe. So it's appropriate that we're building custom evals for every application that we build. And this is kind of a crappy diagram, but I couldn't think of it very well. So what are the things that we're looking for when we're talking about a vibe? Because it is a very indeterminate phrase. When I hear the word vibe, I'm like, what on earth do I mean? First of all, it needs to be something well-defined. So a particular metric like friendliness needs to be something that I can talk to Ryan about, and he say, yeah, I understand what friendliness is. I also understand what friendliness is. We might not agree on a 1 to 5 scale, but we can agree that a particular model is giving an unfriendly return or a friendly one. It needs to be differentiating, in as much as we need to be able to compare one model to the other, one system to the other, or one version to the other. Let's say the Monday version versus the Friday version. Say, okay, how are they different? If our evals do not achieve that differentiation, no good. And most importantly, the final one, it needs to be user aligned. I was really tempted to say customer aligned. We talk a lot about users in tech, but users are customers, and customers pay for our dinner. So I think it's not such a bad thing to think about it that way instead of just as users. So a really good vibe style measurement needs to cover all 3 of these things. Otherwise, it is mere puffery and you are wasting your time. So again, just a comparison of some of the metrics that we're looking at. This one is incorrect. Ignore that. My bad. So traditional numeric summaries like F1, Bleu, Rouge, all of those sort of things are super useful when we are training models and we are comparing how well one model performs out of the box to another. But they tell us absolutely nothing about how it delivers the message. I had a model that I trained up just recently that scored very, very well on Bleu. But when I tested it out, it didn't have any spaces. All the words ran together. A case in point of why these metrics don't help very much when it comes to customer-facing user experience. But they are really important when it comes to building and training your models. Prediction system correctness. Now, why do I keep harping back to a traditional ML? I think more and more that we're going to move towards a system where our tool calls involve calling other models that are not language models that do something specialized. So let's say hypothetically I built a system that was all about procurement. And I wanted to know what raw materials do I need to procure over the next 6-month period based on forecast sales and forecast delivery times and the other things that go into optimizing your supply chain. This is not something that large language models do well. In fact, it's one of the worst things they score on is time series. So why get it to do it? In the same way that we know LLMs are not so good at maths, we give them a calculator. Why wouldn't you give your agent access to an XGBoost model that forecasts awesomely? I think you should. So we still need to be doing predictions of system correctness and measuring drift on those, let's call them sub-models, that we're allowing our primary agents and our primary models to access. And finally is this automated vibe-based metrics that we were talking about, where we're collecting throughout the user's interaction with the model information that allows us to assess these seemingly qualitative elements that are so critical to make it work. Now, LLM as a judge, it still kind of makes me laugh, but it's become incredibly popular in such a short time. It must have legs. So I think the first paper was written around 2023, but it's now become almost industry standard to use LLM as a judge. There's 2 ways that I've seen it done, and I'm sure there's a ton more, but these 2 stick in my mind. The first is when we're comparing 2 different models. Sometimes we'll use a human to judge the difference, but very often we'll use a third model to assess which one is more friendly or which one is more not friendly. The second way is during deployment, when we're wanting to detect changes in drift, we might have a set of gold standard questions, critical questions that we know need to be answered in a certain way, with a certain tone, with a certain accuracy. And we can use a better model, a different model, to ask our production model those questions and assess the answers. Doing so has its challenges, but in general, it's actually a very effective, very fast, very automated way to perform this on a regular basis. It's obviously impractical to have human beings combing through God knows how many logs that you're going to accumulate during a week of normal production use. Automate the thing, LLM as a judge works, with a few caveats. We mentioned before about the order bias. It tends to like things in a certain sequence. The other problem is that it's biased for its own returns. So as an example, if one of the models you're assessing is GPT-4, don't use GPT-5. Bad idea. Bad idea. It always says that it's good. Yeah. Go figure. Look, I guess it's the same as you or me. If we go out and write a story or write an article or do a presentation, we probably feel, hey, I did an awesome job. Someone else out there might feel entirely differently. So in general, if you're going to use LLM as a judge, don't use a model from the same family. Bad idea. Personality fit. Now this, again, was the one that I kind of struggled to get my head around. So as a bit more of a traditionalist, I always want my numbers to be the best. If I can get the best possible score, if I can rank highest on the leaderboard, I feel pretty good about things. But when it comes to interactions between your app and your consumers, it doesn't quite work like that. In fact, the medium is a better place to be. Medium personalities usually get the best and most positive responses from the users. If it's too low, as in too unfriendly, it rates very badly. And sorry to keep going back to friendly, but it's the one that keeps coming to me. If it's too high and friendly, it also rates badly because users feel like this thing is just telling me what I want to hear. Everything I say, it says, hey, that's an awesome idea. You're absolutely correct, exactly right. And it feels sycophantic and untrue. So in general, personality fit trends towards the mean, which is kind of interesting. So yeah, this is kind of just a restatement of how we should think about these things. The basic metrics are about keeping it alive, evals are about keeping it correct, and the vibe metrics are about keeping it human. So bringing it all together and trying to wrap this thing up, LLMOps and LLM observability is really about these three things. We want a stable system. We want to have insights into how the model behaves, why it returns certain things. We want to be sure it's not hallucinating. We want to be sure it's returning correct answers, et cetera, et cetera. And we want to make sure that its vibe is aligned with user expectations. If you can measure these things, you can manage these things. This is a quote that goes back to a guy named Peter Drucker, who I think was writing in the 60s, long before AI was a thing. But that which is measured gets managed is just as true today as it was back then. So I think that these are the three things that we should be capturing data about and then using that data to optimize our product on an ongoing basis. And that's about it. Thank you very much. So I guess as a closing note, for me, I think the missing piece of the discussion is that our users want to feel some kind of bond, some kind of connection with the LLM. And that's not something we ever talk about in observability, and goddamn we should. Thank you. Oh, any questions? Yeah.
Question. So you mentioned about LLM evaluations. So starting from that, in terms of an improvement of the responses, will you actually look onto like context engineering?
Yes.
Prompt engineering?
Yes.
Models?
Yes.
RAG, tools calls?
All of that stuff.
Yeah?
Yep.
All of those stuff? So
all of them are options, right?
How would you actually structure kind of the plan for the improvements and like bringing forward to the next step and get your responses much more satisfying?
So it's only good to change one thing at a time. And when we have a long menu of potential knobs that we can twiddle, that can be risky. I don't think it's wise to change more than one thing at once. So I would generally start by brainstorming and coming up with a list of all of the things that we think are potential culprits for this drift. Start with what you think is the most likely. Move the big rocks first. And the one that's most likely often is the most difficult one, and there's a human propensity to put off hard things. We want to start with the easy one. I would argue against that. Start with the hardest one, and then if that delivers the result you want, great. If not, tick it off, move on to the next one. But throughout, record. Brains are great at having ideas, not so good at keeping them. So make sure we record. And it's the same reason I think observability needs to start at conception and continue through development, because it's once we're ready to go live and go into production, then we've established the baseline for what we think good looks like. And if you don't have all of those records leading up to that point, how do you know what good looks like?
Oh, actually, I have an add-on question as well.
Sure.
You mentioned about personality, right? So I reckon it is something kind of like ChatGPT, where you interact, it has like a memory of the people.
Yes.
It's able to interact with. Is there something offering on like AWS, Agent Core or what?
So we talked about long-term memory. And yes, you can accumulate user preferences in long-term memory so that even after your session with a particular user is finished, once that user logs back in and starts the chat again, it can retrieve all of those preferences and the information that's given to you in the past and so on in order to tailor its tone and other things to meet that user preference. Yes?
Thank you for your talk. I learned quite a few things. I think it was quite, got me thinking about a few things as well. Just one tiny point, you said we all know large language models are no good at maths. I think you said it slightly in jest.
No, I'm serious.
I'd just like to challenge that.
Sure.
I think they weren't any good at maths, maybe 18 months ago. This year, both OpenAI and Gemini produced large language models which won gold medals at the International Mathematics Olympiad, which sets some of the hardest maths problems out there for normally 18 to 21-year-olds to solve. So on that basis, I'd suggest that actually they are pretty good at maths. But I thought you were jesting a little bit, but that's the challenge I'm just putting forward.
Accepted. I'd say you're more trusting than me. There was a scandal a little while back around Llama 4, I think it was, where Meta was touting fantastic maths performance on the same benchmarks. And some days or weeks after release of these results, there was a leak to say that, well, actually, we trained it on the questions and answers.
Maybe I'm just too trusting.
I'm not sure. I would love for LLMs to be great, but I had this experience helping my son with chemistry homework the other night. I asked, it was a loaded question because I knew the answer, and I said, if you have 1 litre of pure hydrochloric acid, how many litres of pure water does it take to take the pH down to below 8? Now, I know the answer to that. GPT told me 176 million litres of water, which is bollocks.
It's 174, right?
It's in the tens of thousands.
Yeah.
Can you bring a slide up?
Of course.
Second last one, because you just summed it up there. The system, the accuracy, and... Sorry.
Was that one before?
Yeah. No, that one, well, it could be, go back to the table. This one.
Yeah.
So you've got your metrics, your evals, and your biometrics. Do you have to build them up in that order? In my mind, it feels like they're getting more complex as you go through that.
Yeah.
Is it worth, for example, collecting vibe metrics if you maybe don't have great system reliability metrics?
Absolutely.
Okay.
It's poor presentation on my part to imply that one needs to follow the other. I would be collecting things like evals and vibe metrics while it's still in development, running on my local computer, at which point in time, I don't care about system at that point.
Okay, cool.
Can I add on to that?
Yeah.
Do you think there's a weighting to them? Are either of those more important than the other?
If you had to pick, which one would you start with?
I'd start... Well, I think it's hard to avoid the basic system stuff being the most important, because if your system is down, well, you don't have a product. So nothing else matters. As to whether the other two are more or less important, I think it's really context dependent. There are some domains, I'm going to pick on medicine, where accuracy is more important than tone. Law might be the same. Haven't had enough exposure. Other domains, the tone is super important. So I think it's hard to give a hard answer on that one. So,
just wanted to point out something about
sure.
LangGraph, because you mentioned that.
Yes.
So if you use LangGraph with LangFuse, which I haven't, you probably need to write a bit of code to like
Yes.
do the tracing.
Yes.
But if you use it with LangSmith, which is from the same company as LangGraph, which is LangChain, all you need to do is make the API key available in the environment.
There you go.
Sorry to
Take note. No, it's good. It's great. It is, and it's so hard to stay across them. I confess I started out using LangChain, but when they introduced LCEL, this LangChain expression language, yeah, I don't like it. But yeah, I'm sure that's correct. So take note, everyone. There's so many offerings out there. I don't think that there's a definitive one way to do it. I am biased to the AWS thing just because I'm lazy, and it's all there. Any other questions? Yes, sir.
What's your take on the scale you'd need for those vibe metrics to be meaningful?
Oh man, that's a good question. I don't know the answer, to be honest. Can I think about it and get back to you?
Oh, any takers? Anyone has an opinion?
What scale would you need for those vibe metrics to become statistically meaningful?
It's rooted in, like, even just doing basic A/B testing.
Yeah.
Like, I've moved a button on my web page and I want to know if I've got a better conversion. You have to be bigger than any business I've ran to be able to do that.
It's a very valid point. Yeah, I'll come back to you.
Well, we can ask AI.
No way.
76 million.
Any more questions?
No. Thank you very much, everyone.
Thanks, Michael.
I'll put the slides up on the Slack channel. I did do a demo, but it ended up being way too long, so I cut it. It's really easy to run. I'll post the repo for that as well. I added a makefile, so all you need to do is run the makefile and demo will go. Thank you.
That's the end of the meeting. Before I let you go, we have housekeeping, as you know. So next meetup is up on the 20th of November. So if you'd like to join, the event is up on Meetup. Please go and register. Don't have to do it right now, but make sure you do it before the 20th of November. If you'd like to speak here, feel free to submit a session. We have a tool called Sessionize, which is a little synopsis of what you like to talk about. And there's a hot from the press. The What's New session is up for grab as well. It doesn't necessarily have to be an AWS person. The way we approach it is like one of us goes through the announcement and pick their favorite, the more useful, whatever they like to share. So if anyone wants to try to present and they don't know what to talk about, they can try and grab the What's New. So if you're interested, put a message or reach out to one of us and we can talk you through. And then if you have any other topic, feel free to submit your session. Community relationship, we've got a Slack channel and a YouTube channel. We normally post the talk when we have our audio tech guy here. So you can find the past meetup and futures. And then the Slack channel where you can just send us a message. The slide will be posted on there. So if you want to be in touch. And last but not least, obviously, thank you for coming. And there's a feedback form. So if you have any feedback, good, bad, help us improve, or pat us on the back, whatever, let us know. Hopefully the form works. Sometimes we have challenges, but you should be able to scan it and load it on your phone. And that's...
There's also feedback on the speakers as well, guys, which we like to pass on. So
can we leave the room fast?
Yeah.
It's all anonymous. I will find you. And that's everything for tonight. Thanks a lot for coming, and hope to see you soon.